So is my screen visible to all of you guys? Is my screen visible to all of you? Is my voice audible, guys? Okay, nice. So welcome to week 9 discussion of this course, Farm Machinery, and this course was taken by Professor V.K. Tiwari, Director IIT Kharagpur, and Professor Agricultural and Food Engineering Department, IIT Kharagpur. And myself, Ayan Paul, I am a PMRF research scholar from IIT Kharagpur, and I am TA of this course. And by TA I mean PMRF TA. My duties are, I will first discuss you the summary related to all the lectures covered in this week, and second I will discuss with you some questions that are very similar to your assignment question, so when you will do the assignment you will not feel alienated. So let's start the discussion. So you must have gone through your lectures, and in this week 2 of the lectures are regarding problems on spraying equipment. Okay, problem based on design and selection of spraying equipment. So I will also discuss some problems based on this. So this is the first problem: a field sprayer having horizontal boom with 20 nozzles spaced 46 centimeter apart is to be designed for a maximum application rate of 750 liter per hectare at 520 kilopascal and 6.5 kilometer per hour. So what have been we given? We have been given number of nozzles. This is the number of nozzles, okay, 20, and then we have been given nozzle spacing, that is 46 centimeter, okay, 46 centimeter, and then we have been given application rate of this nozzle, that is 750 liter per hectare, and we have been given pressure of the nozzle, that is 520 kilopascal, and also the speed of the sprayer, that is 6.5 kilometer per hour. Now we have been asked 4 questions. First part of the question is, determine the required pump capacity in liters per minute assuming 10% of the flow is bypassed under the above maximum condition. So we have been required to find out the pump capacity in liters per minute in the first part. Okay, so how we will find it? These are our given that I have already told you. Now we have been asked to find out the pump capacity. So pump capacity, how to find out the pump capacity? Pump capacity is maximum application rate of the nozzle into area covered per hour. Actually this part, maximum application rate is given, that is 750 liter per hectare, okay, liter per hectare. This has been given to us. Now second thing, what have been given? We have been given nozzle spacing and we have been given speed. So I have already told you, if we have application rate and we have field capacity. So field capacity, unit of field capacity is hectare per hour. So we can get the pump capacity in liters per hour, because hectare will get cancelled out. So our answer will be in liter per hour. And when we will find liter per hour, we can convert. If we divide this hour by 60, if we divide it by 60, so we can get our pump capacity in liter per minute. So this is already given, that is 750 liter per hour per hectare. Now we have to just find out the field capacity. How we can find out the field capacity? Field capacity is speed into width of the implement divided by 10. Okay, speed in meter. Okay, speed in kilometer per hour. And width in meter. When we will do this, we will get our field capacity in hectare per hour. Okay, and as we have to find the field capacity in hectare per minute, because we want this answer to be in liter per minute, so we have to multiply 60 with it. Okay, so if we will apply this formula, that is maximum application rate into speed into width of the implement divided by 600, you will get the answer. Okay, so maximum application rate, it is already given 750 liter per hectare. Speed is given 6.5 kilometer per hour, so this is also given. Now width of the implement, how we will find? We have been given nozzle spacing, that is 46, and we have also been given number of nozzles, that is 20. So how to find out field capacity? Your speed is 6.5. okay, this is fixed. Now width is, we have 20 nozzles, and we have and each nozzle is 46 centimeter apart, but we want our width in meters, so we will multiply by 0.46. 46 centimeter, that is 0.46 meter, divided by 600. okay, and our application rate was 750. So 750 into 6.5 into 20 into 0.46 divided by 600. When we will do this calculation, you will get your pump capacity in liter per minute, and your pump capacity coming here is, if you can solve, you can solve, otherwise after this class also you can solve. Your pump capacity will come 75.75 liter per minute. okay, up to this I think it is clear, but the question is still not complete. The question is asking, assuming 10% of the flow is bypassed under the above condition, that means we required 10% extra flow for our pump. So how to convert it? 10% extra, we just have to multiply 1.1 to it. okay, 1.1, when we will multiply 1.1 to it, our pump capacity will come with losses. okay, considering 10% losses, we just have to multiply this value with 1.1. okay, I think here, I think 74.75, here it is written 75.75, but 74.75 will come when you will do the calculation. To 74.75 into 1.1, when we will do, you will get the final answer. okay, that is 82.225 liter per minute. So this part is over. okay, any doubt in this part? You may please ask. Any doubt? Okay, so I guess no doubt in this. Let me move forward. So this, our first part is over. What is the second part? Second part is, if mechanical agitation requires 375 input watt and pump efficiency is 50%, what should be the engine rating if the engine is to be loaded not more than 80% of its rated power? So you just consider, as of now, you just consider that you have to find out power. okay, what is power? Power, I have already told you the formula for power. Power is flow rate into operating pressure. So flow rate, we already got the flow rate, that is 82.225 liter per minute. okay, and we have the operating pressure also given, that is 520 kilopascal. When we will do this, we will take care of the units. Liter we have to convert in meter cube, that is why into 10 raised to the minus 3, and minute we have to convert in second, that is why 60 minute, 1 minute equals to 60 seconds, that is why divided by 60. So unit conversion you have to take care. Similarly here also you have to take care the unit conversion, 520 into 1000, because this is kilopascal, we want in pascal, so that is why into 1000. So when you will do that, you will get your power in watts, but normally we want our power in kilowatt, so we have to divide it by 1000, that is why 0.713 kilowatt. So up to this it is clear, but thing is, here the extra information is given. What extra information is given? First thing is given, if the mechanical agitation required 375 input watt and the pump efficiency is 50%, what should be the engine rating if the engine is to be loaded not more than 80% of the rated power? So we have three things. One is the mechanical agitation power is given, that is 375 input watt. Second is pump efficiency is given. Third is we have to operate this pump in 80% rated power. These three things are given. So we have to take care of all these three things. So first what we will do, we will do the pump efficiency part. Okay. So pump efficiency part, our power brake horsepower has come, but we want this is the this is the output power, but we want what is the input power. So input power, how you will find out the input power? Efficiency is what? Output by input. So if you will take input this side, so output divided by efficiency will give you your power. So 7.713 we already got, and if we divide it by pump efficiency, that is 50% or 0.5, we will get our actual brake horsepower. Okay, so up to this I think it will be clear. Now this part we have taken care. Okay, this pump efficiency we have taken care. Now we have been left with these two things. One is mechanical agitation, second is 80% rated power. These two things we are left with. So for mechanical agitation, it has been given that we require 375 watt for mechanical agitation. So 375 watt is 0.375 kilowatt. So this power plus the power for mechanical agitation, we will get a total power, that is 1.801 kilowatt. Now we have to operate this at 80%, that is the maximum we can operate. So we have to again divide by 0.8 or 80%. So we will get our required power for operating the pump. Okay, so this is our second part. Okay, second part is also over. Now we have been left with third part and fourth part of the question. So third part is what is the discharge rate. Okay, so third part is what is the discharge rate per nozzle in liter per minute is required under the above condition. So here what we got the here we got the flow rate of the pump. Okay, so where the flow will go, the flow will go to the individual nozzle. Okay, this total flow will go to the individual nozzle. Okay, so individual nozzle, we have 20 nozzles, so each nozzle we will get this divided by 20. When we will do, we will get 74.5. Here in this question what has been done is the loss is not considered. Okay, loss is not considered when we are calculating the nozzle flow rate. Okay, so this 74.75 liter is considered. So without loss we are considering. So without loss discharge divided by total number of nozzles, that is we have in this question we have 20 nozzles. So we will get discharge per nozzle. Okay, and now we have been left with last part, that is if the nozzle have 70 degree spray angle and the pattern is such that 50% overlap is needed for uniform coverage, at what height above the top of the plant should the boom be operated. So nothing, they are asking what should be the height of the nozzle, that is they are asking, and they have been given additional information. They have been given additional information. First additional information is 70 degree spray angle. Second additional information is 50% overlap. Okay, these are the two additional information given. So we will be checking the geometry of the spray, geometry of the nozzle. So here this is one nozzle, this is the second nozzle, and in the first part of the question only we know that the nozzle spacing is 46 centimeter apart. So the distance between this nozzle, let me mark it 1, and this nozzle let me mark it 2. So first nozzle and second nozzle, the distance between this is given, that is 46 centimeter. Now when the nozzle are close to each other, there will be some overlapping of the spray. You know that most of the nozzle will give you a triangular shape of spray pattern. So this nozzle is also giving triangular shape of spray pattern, this nozzle is also giving triangular shape of spray pattern. But it has been given in the question that there is a 50% overlap between this two spray pattern. Okay, so this is the overlap, 50% overlap. So this spray pattern and this spray pattern is overlapping, and this very part is your spray overlap, and that is given 50% of the nozzle spacing. So nozzle spacing is 46 centimeter. So 50% of nozzle spacing will be 23 centimeter. So this thing is given. Okay, this thing is given. Now we have been asked to find out this, or height of the nozzle. This we have to find, that is capital H. So how we will find out capital H? We will take two triangle. we will take this triangle. Let me mark it A. This point is A. This point is B. Let me mark it B. This point is C. Now similarly, if you will okay, let me erase it first. Okay, so this is A, this is B, this is C. Now this is also a triangle, right? This is a triangle. Similarly, will also be triangle. So this, let me mark it as A dash and let me mark it as B dash. Okay, so we have two triangle ABC and A dash B dash C. So we have this two triangle, and this two triangle ABC, okay, triangle ABC is similar to triangle A dash B dash C. This two triangle are similar to each other. This triangle ABC and this triangle A dash B dash C is similar to each other. Okay, now as they are similar to each other, so this side, that is capital H, this side is capital H, and this side is small h. So capital H divided by small h will be equal to BC divided by B dash C. Okay, so this we know. Now the question is, what is small h and what is BC? We already know. How we know BC? We know this is 46 centimeter. Okay, this is 46 centimeter. So and we have been given 50% overlap. So this total will be 46 plus 23 centimeter. This is total D. So if we know the total D, we can get D by 2. D by 2 will be 46 plus 23 divided by 2. So that will be D by 2. So this BC we also know, that is that will be equal to 46 plus 23 divided by 2. That means 69 divided by 2. So that will be equal to 69 divided by 2. Okay, so BC we know, and B dash C also we know, because this will be half of it. So that means it is 23. So 23 divided by 2. So we know BC, we know B dash C, but we don't know H. So how to find out H? So H we can also find out. We can take this triangle, and as this is 35 degree, this is also 35 degree. Okay, this is also 35 degree. So tan 35 degree will be equal to B dash C divided by A dash B dash, and A dash B dash is your H. Okay, A dash B dash is your H. So H will be equal to this 23 by 2 or 11.5 divided by tan of 35 degree. So H we got 16.42 centimeter. So H we got, we know this. So capital H will be equal to this we got 16.42, small h 16.42. Okay, and this we can calculate, this we can cut, and this we can cut. So 3. Okay, so 16.42 into 3, that will be your capital H, and capital H will come out to be 49.27 centimeter. So your D part is also over. C part is over and D part is also over. So any doubt in this question, any part? Please ask. Any doubt in this question? You can please ask. Any doubt, any question? Okay, so I guess this parts are clear. So our first question is over. Similarly, we will move to the next question. Okay, so this is a problem second, and here what has been given, an air blast sprayer is to be operated at 4 km per hour. So speed is given. This is the speed. Okay, speed is given. Desired application rate is 19 liter per tree. So here it is not given liter per hour, it is given liter per tree. Okay, 19 liter per tree. Normally our application rate will be in liter per minute or liter per hour, but here your application rate is given as liter per tree. So for each tree we should spray 19 liter. So that is given. Now the spacing between the tree is given, that is 9 into 9 meter. Okay, and each nozzle delivers 4 liter per minute. okay, at operating pressure 415 kilopascal. So nozzle application rate is given, that is 4 liter per minute, and operating pressure of the nozzle is given 415 kilopascal. Now here is first question it has been asked, if one half of the row is sprayed from each side, okay, so it is a boom kind of sprayer. So your sprayer will be like this. So it has nozzle on both sides, okay, it has nozzle on this side also and it has nozzle on this side also, okay, and here will be your tree line, this is your tree line TR, and here will be your another tree line TR. So these are your two tree line, one tree line and another tree line, and in between this is your sprayer, and your sprayer has nozzles on both sides, okay, this side also it has nozzles to spray to this tree line, let it be tree line 1 and let it be tree line 2. So to spray to tree line 1 we have our nozzles at the left portion, and similarly to spray for tree line 2 we have our nozzles on the right portion, okay. So this is your sprayer, and in this sprayer will be operating between two tree lines, okay. Now here first question it has been asked, if one half of the row is sprayed from each side of the machine, how many nozzles we needed. So how we will find out? These are your given, I have already discussed. Now what is the net discharge that is coming on one side, that we should know. So how we will know? This is the 4 liter per minute, that is by one nozzle. Now let n be the number of nozzle on one side, okay. So 4 into n, that will be discharged from one side of the sprayer, okay. 4 into n is the number of nozzle on each side, so that will be discharged. 4 liter per minute for one nozzle, and if you have n nozzle on one side, so 4 into n, that will be your net discharge on one side, okay. Now we also know that the for each tree this is the desired application rate, that is 19 liter per tree, okay, that we also know. Now what we will do, we know this speed is 4 km per hour. So speed is distance upon time, and distance one as the tree spacing is 9 meter. So distance, if this is your distance and your speed is 4 km per hour, 4 km per hour means 4 into 5 by 18, that means 4 into 5 by 18, 5 by 18 means 1000 by 3600. Kilometer is 1000 meter and hour is 3600 second. So 1000 by 3600, 1000 by 3600, we write it as 5 by 18, we convert it as and write it as 5 by 18. So 4 into 5 by 18, that is your speed, and distance you know. So you can get the time for each tree, what is the time you require, that you can get. So T you can get, okay, T you can get 9 by 4 into 5 by 18, 4 into 5 by 18. So time we will get. So time is coming for each tree, you have to give 8.1 second. Okay, this is the time you have to give to this is the time you have to give it to one tree. Okay. Now thing is the application rate is already given. Application rate for each tree is given 19 liter per tree. But we have find out the application rate as 4 into n into time required for each tree. So that by that we can get the application rate. 4 into n is the number of nozzles and t is the time required for one tree. So this time unit will cut down, like here 4 into n, 4 into n, 4 into n is 4n, 4n liter per minute. Okay, liter per minute. This is your net discharge from nozzles on one side, that we know. We also know the time for each tree. Okay, so time for each tree 8.1 second, that you can convert in minute, that is 8.1 divided by 60. So we can get okay, let me erase this first. Yeah, so I was telling 4n liter per minute is your discharge rate on one side, and for each tree you require 8.1 second. So 8.1 second is 8.1 by 60 minute. Okay, this much minute. So this minute and this minute will cut down, and you will get your your application rate for each tree, this 4 into n into 8.1 by 60. But you already know your application rate for each tree is 19 liter per tree. So if you will solve this, you will get n, that is number of nozzles. So number of nozzles, here it is coming 35.18. So you know the number of nozzles cannot be in decimals, we have to take it as a whole number. So we are taking one more than this. So 35.18, one more is 36. So your number of nozzles on one side of your sprayer is 36. Now what will be the number of nozzles on both the side of the sprayer? 36 into 2, because 36 on one side, 36 will be on another side. So 36 into 2, that your total number of nozzle will be equal to 72. So our first part is over. Now the question has been asked, how many hectares can be covered with a 2 meter cube tank of full spray? Now we have 72 nozzles that we have just calculated, and our discharge rate per nozzle is 4 liter per minute. So our total discharge will come 72 into 4, that is 288 liter per minute. Okay, now 288 liter per minute, we can convert this liter in meter cube. 1 liter equals to 10 raised to the power minus 3 meter cube. So 288 into 10 raised to the power minus 3 meter cube per minute, that is your discharge. So 288 into 10 raised to a minus 3 meter cube per minute. If we will divide the total tank capacity 2 meter cube divided by 288 into 10 raised to power minus 3 meter cube per minute, we will get time required to apply this much chemical. So that will be coming as 6.94 minutes. Now it has been asked how many hectare can be covered for this. So hectare, how we will find out this? Again we will take the help of the field capacity thing. Okay, so how we will take the field capacity thing? Here see, we have this 4 is your 4. Okay, somebody is joining, I think. Yeah. So 6.94, this is the minute, into 4 into 1000 by 60. Why 4 into 1000 by 60? Because this is your speed. Okay, so this is your speed into 9 meters. So by this we can get your hectare. So again I am repeating, time we know, we get time from this 2 meter cube. When we will divide by total discharge, we will get the time we know. Now we also know that speed, that is 4 kilometer per hour. Okay, 4 kilometer per hour means 4 into 5 by 18 4 into 5 by 18 meter per second. Okay, and this 6.94 minute means 6.94 into 60. So 6.94 into 60 into 4 into 5 by 18 into 9, because this is your spacing between each tree. So into 9. So when we will do this, we will get the total hectare that is covered in this much minute, that is 0.42 hectare. So is this part clear to all of you? Any doubt? Any doubt in this problem? So let me move to the next question. So next question is, the manufacturer of the pressure nozzle specifies that a volume medium diameter 135 millimeter is obtained at 345 kilopascal using water. Okay, so manufacturer is testing the nozzle first with the help of water, and he found that the volume median diameter coming out of the sprayer is 135 millimeter at 345 kilopascal pressure using water. Okay, he is using water first. The same nozzle is to be used for a chemical. Okay, we have to use our nozzle for chemical, not with water. Okay, whose surface tension is 50 dynes per centimeter. So determine the volume median diameter droplet if the nozzle is to be operated at 525 kilopascal. So here's the dynamic. What has been given? The manufacturer is first testing your nozzle with the help of water. When he is using with the help of water, this is your median diameter, that is coming 135 millimeter at this much pressure. Now now the same nozzle has to be tested with a chemical. Okay, now when it is tested with a chemical, its surface tension changes, that is 50 dynes per centimeter. Surface tension is changing. Second thing what is been changing is the pressure is also changing. So we have to first change the chemical, that is the surface tension. Second, we have to also change the pressure. So then we have to find out what is the volume median diameter of that chemical droplet. So we have two variables, one is surface tension and another one is pressure, and by that we have to find out the diameter. Okay, two variable, one output, that is diameter. So now we already know this thing, that okay, let me use capital D for it. Okay, you already know this, that is dVmd. dVmd is directly proportional to sigma. Okay, sigma is your surface tension to the power half. You already know this. So when you know this, you can find out the dVmd for for the chemical at same pressure. Here we are applying the same pressure. So dVmd of chemical divided by dVmd of your water, okay, will be equal to sigma of chemical is given, that is 50 dynes, and sigma of water, you have to memorize this, that sigma of water, that is the surface tension of water, is 73 dynes per centimeter. Okay, 73 dynes per centimeter. This is your surface tension of your water. So 50 by 73 divided by 2, because sigma to the power 2, so divided by to the power half. Okay, so this by applying this you can calculate the diameter VMD of chemical. Okay, because you already know the surface tension of chemical is already given, that is 50 dynes per centimeter. You know the surface tension of water, that is 73 dynes per centimeter. So you can get the volume median diameter of the chemical, because this we also know volume median diameter of the water is also given 135 millimeter. So you can get dVmd of the chemical. Okay, so this you know. Now second part is pressure. They are also varying. Pressure, they are varying from 345 kilopascal to 525 kilopascal. So okay, let me erase this. Okay, so pressure, they are also varying. So what is the relation of VMD with pressure? The dVmd 1 by dVmd2, or let me write in this way, dVmd is directly proportional to dVmd is inversely proportional to 1 by p to the power 1 by 3. Okay, this is the formula. So dVmd is inversely proportional to p to the power 1 by 3. This is the formula. So dVmd1, or we can write it as VMD1. We can write it as VMD1 V1 by V2 equals to P2 by P1 to the power 1 by 3. Okay. So we know our volume of chemical, we already know, that is 0.83 into VMD water, that we already know, because 50 by 73 to the power half is 0.83. So this we already know. So as we know this, so our V1 is V2 is fixed. Okay, V2 is fixed. We also know the P2. P2 is 345 kilopascal. Now we have to find P1. We also know that is 525 kilopascal. Now we have to find the V1. So V1 will be equal to V2. That is V2 we got from here. Okay, V2 we got VMD into that is 135 millimeter into 0.83. Okay, that is the V2. So V1 will be equal to V2 into P2 by P1. Okay, what is P2? P2 is your yeah, P2 is your 525 kilopascal. Okay, so sorry, P2 is your 345 kilopascal. 345 divided by 525 to the power 1 by 3. So that will be your answer. So your volume medium diameter of the chemical will come as 0.83 into 0.83 into 135 millimeter into 345 divided by 525 to the power 1 by 3, that is 97.43 millimeter. So again I am repeating, we have two variables. One variable is we are changing the surface tension or we are changing the chemical. So sigma is different, that is surface tension is a variable. Second variable is our pressure. Pressure we are changing from 345 kilopascal to 525 kilopascal. So first thing, when we are changing the surface tension, we have this relationship with surface tension, that is D is directly proportional to sigma to the power half. Okay, that is the relation. So that is why dVm chemical divided by dVm water will be equal to sigma chemical divided by sigma water to the power half. In sigma water we have to memorize this, that will be 73 dynes per centimeter. When we will do this, we will get VMD chemical. VMD chemical will be equal to VMD water, that is 135 into this 0.83. So we will get VMD chemical. So our first part is over. But in the second part, what they are doing, they are also changing the pressure of the nozzle from 345 kilopascal to 525 kilopascal. So we again have to apply a formula, that is VMD1 divided by VMD2 equal to P2 by P1 to the power 1 by 3. So when we will do this, we will get our VMD1 or VMD chemical. That will be equal to this 135 into 0.83, okay, into this, into this 345 divided by 525 to the power 1 by 3. So when you will do this, you will get VMD chemical, that will be coming as 97.43 millimeter. So this is your answer. So any doubt in this question? This is a simple question. Any doubt? You may please ask. Any doubt? Okay, so no doubt. Okay, so let me move to the next question. Okay, so here calculate the suction capacity of a power sprayer if the diameter of the plunger 20 millimeter, speed is 1000 revolution per minute, length of the stroke is 21 millimeter and number of plunger is 3. So here direct question is given. What has been given? Diameter of the plunger is given, that is 20 millimeter. Speed is given 1000 revolution per minute. Into length of the stroke is given 21 millimeter and number of plunger is given 3. So these are the things given. We have been asked to calculate the suction capacity of the pump. So suction capacity same as Q. You can say Q of the nozzle, that is same. Q we apply for nozzle. Here suction capacity of the pump is required. That is why it has been written suction capacity. Otherwise they would have been written discharge of the nozzle or discharge of the pump. So this is the thing. So how we will find out this suction capacity. You know what is volume? Volume of a cylinder is pi by 4 d square, pi by 4 into diameter square into length. This you know volume. But suction capacity or discharge is volume divided by time. So how we will do for volume divided by time? We will simply multiply this volume of the cylinder into this n, that is into this n or the revolution per minute. We will simply multiply it by n. Okay, so when we will do this, we will get our required suction capacity. But here the number of plunger is 3, so we will again have to multiply small n. So again I am repeating, what is the volume of the cylinder? Volume of cylinder is pi by 4 into d square into L. D is the diameter of the cylinder. L is the length of the cylinder. This is the volume of cylinder. Now, what is the suction capacity? When we are asking suction capacity, we are basically asked the Q or the discharge. So, discharge is volume divided by time. So, how we can find volume divided by time? We have not given any time. But what we have been given? We have been given the speed of the RPM of the cylinder, that is capital N we are given. So, we have to just multiply this volume into this revolution of the pump, that is capital N, and also we have been given number of plungers, so small n. Small n is the number of plunger and capital N is the RPM of the pump. So by this formula we can get your suction capacity. So here same thing has been done, pi by 4 into d square. D is 20 millimeter. 20 millimeter we have to convert in meter, so 20 into 10 raised to the power minus 3, that is 0.02. So that has been written, pi by 4 into d square, so 0.02 square into L. L is stroke length is 21 millimeter. Again 21 millimeter we have to convert in meter, so 21 into 10 raised to the minus 3. So that has been done. 21 into 10 raised to the minus 3 is 0.021. Now we have to multiply it by capital N. Capital N is the RPM of the pump, that is given 1000 revolution per minute. So again minute we have to convert in second, so 1000 divided by 60 second, because 1 minute equals to 60 seconds. So 1000 divided by 60. Now number of plunger is 3. So when you will do this, you will get suction capacity of the sprayer or suction capacity of the pump. Okay, this you know. Now second part. So this part is over. So I think this part is clear to you all. Now move on to the second part. Calculate the shaft power in kilowatt when pressure is 30 kg per centimeter square, suction volume is 26 liter per minute, and the pump efficiency is 65%. So again, what is power? Power capital P is equal to, so this is power, capital P is equal to small p, that is pressure into discharge. Pressure is given 30 kg per centimeter square, that we have to convert in Newton per meter square. So 30 kg is 9.8. Okay, 9.8 we have to multiply from kg to Newton, 9.81 divided by centimeter square. Centimeter square we have to convert in meter square, that is 10 raised to the power minus 4. So P we got. Now Q. Q is also given 26 liter per minute. So 26.4. Okay, liter is 10 raised to the power minus 3 meter cube. Okay, divided by minute. Minute we have to convert in second, so 60 second. So by this we will get power, but this power is your output power. We have to find out the input power. So how we can find out input power? Efficiency is what? Efficiency is output by input. I have told you we got output power. We have to got input power. So input is output by efficiency. Output by efficiency. So simply if we divide efficiency in this calculation, so we will get our output power of the shaft, and efficiency is 65%, so 0.65. So when you will do this calculation, you will get the shaft power of the pump. Okay, same thing here they have done, Q into P divided by efficiency. So Q into P, again same thing, right? Let's see, 30 into 9.81 into 10 raised to power, they have taken this 10 raised to power minus 4 in the numerator. So then 26.4 into 10 raised to power minus 3 divided by 60 into 0.65. So by this you will get shaft power in watt. If you want kilowatt, then you have to again divide it by 1000. Okay, again you have to divide it by 1000. So when you will divide it by 1000, you will get shaft power in kilowatt. So this is also over. Now what length of the boom is needed on a sprayer operating at 8 km per hour to permit spraying 32 hectare of field in 8 working hours? The time lost in filling the tank is tank and in turning is 30%. So let me delete this. Now yeah, so here what has been given, we have been given the length of the boom we have to find out, needed on a sprayer operating at 8 kilometer per hour. So we have been given speed, we have also been given hectare, means this is the actual area covered, this is the actual area covered AA. In time is also given TA, this is the actual time. So this we know that actually the sprayer is covering 32 hectare in 8 hours, and also this time lost in filling is given 30%. So we have to find out the length of the boom. So how we can find out? We know what is efficiency. Efficiency is output by input, but efficiency, field efficiency is your actual field capacity, AFC, divided by your theoretical field capacity. Okay, now how we can find this field efficiency? Here has been given 30% time is lost in turning and filling the tank. So field efficiency we can calculate 100 divided by 100 plus 30, because 30% time is lost. So T divided by T plus 30, or 100 divided by 100 plus 30. When you will do this, you will get the field efficiency. So this we know. Now, do we know AFC? Yes, we know AFC. How we know AFC? AFC is your actual area covered, that is AA, divided by total time taken or actual time taken, that is TA. So actual area covered is 32 hectare and 8 hour is given. So your AFC will be given, you will be coming 32 divided by 8, that is 4 hectare per hour. So your AFC is also clear. So let me delete this. Your AFC is also covered, that is 32 by 8, that is 4 hectare per hour. Now what is TFC? TFC I have told you many times. TFC is S into W divided by 10. TFC is theoretical field capacity, that is S into W divided by 10. And in this question we have been asked to find out length of the boom, or we have been asked to find out this. We have been given the speed, that is 8. So your this equation will become, efficiency will get 76.92 or 0.7692. Efficiency we know. We also know the actual field capacity, that is 4. We know the speed, that is 8 km per hour. But we don't know the W, that is length of the boom, or we can say width of the boom, divided by 10. So when you will solve this, you will find the W, or the width of the boom, or the length of the boom. So your length of the boom, when you will do the calculation, your length of the boom will be coming 6.5 meter. So is this clear, this question? Any doubt in any part? Any doubt in any part in this question? Okay, no response. Okay, so I hope this part is clear to all of you. So let me move to the next question. This will be the last problem question. So here a hydraulic sprayer fitted with hollow cone nozzle is required to be calibrated for an application rate 150 liter per hectare. The application rate is given. Second thing, the sprayer speed of the sprayer is given 6.5 km per hour. Nozzle spacing is given 50 centimeter. Now the available 0.787 millimeter orifice diameter is given, is rated, orifice diameter is given, and also the flow rate of the nozzle is given, that is 0.473 liter per minute, and also the pressure of the nozzle is given 275 kilopascal. Now calculate the nozzle flow rate, that we have to calculate. Okay, so nozzle flow rate, how we will calculate? So nozzle flow rate we can calculate by this formula. Okay, Qn equals to application rate into our field capacity divided by 60 into 10. Okay, that I have already repeated again and again. So application rate is given 150 liter per hectare. Your S, or the speed, is given 6.5 km per hour, and speed, this V is used here for speed, that is 6.5 km per hour, and the spacing between the nozzle is 50 centimeter, that is 0.5. so by this you can get application rate, you can get the nozzle flow rate. Okay, by this formula you can get the nozzle flow rate. So again I am repeating, what will be the nozzle flow rate? Nozzle flow rate will be equal to application rate into field capacity divided by 60. Okay, field capacity, how we will find field capacity? Field capacity is S into W by 10. S is your speed and W is your width. Okay, so by that you can find out your nozzle flow rate. So A portion is over. Now B portion, the pressure required to produce the desired nozzle flow rate. So your desired nozzle flow rate is this. Okay, but we have been given rated flow rate 0.473 at this much pressure. So we know this formula, P is directly proportional to Q square. Okay, so P1 by P2 will be equal to Q1 by Q2 square. Okay, now do we know P1? Yeah, we know P1. This is your P1. Let's say this is your P1. So P1 we know Q1. Yeah, we also know Q1. We know P2. We don't know the P2. P2 we have to find out, but we know the Q2. Q2 is 0.812. This we also know. So P1 we know, Q1 we know, Q2 we know. We can find out the P2. So same thing they have used. What they have done, they have made Q is directly proportional to root P. Same thing, because if you will square root on both sides, so root P will be proportional to Q. So that formula they have applied. So same thing, same here also. If you will apply this formula also, you will get the same answer. So P2 will be coming 806.45 kilopascal. So this is also clear. Now the droplet size at desired flow rate, if the nozzle produces a VMD 200 micrometer at 1000 kilopascal. So the droplet size is related to pressure by this formula. D2 by D1 is equal to root 2 P1 by P2. That means the diameter of the droplet is directly proportional to inversely proportional to your pressure, P1 by 2. That is the formula. Diameter of nozzle is inversely proportional to root over P. That is the formula. So that formula when we will apply to, so D2 by D1 will be equal to P1 by P2 root over D2. We don't know D2, but we know D1. D1 that is given D1 is given 0.787. So this we know. Okay, this we know. 0.787 we have been given. This we know. Now D2 we can find out. D2 will be equal to root over P1 by P2. So by this we can find out the D2, that is 227.71 micrometer. Okay, not this. Yeah, we have been given VMD 200 micrometer at 1000 kilopascal. So D2 by 200 equals to root over what is P1? P1 is 1000 kilopascal. 200 correspond to 1000 kilopascal. Now D2 for this 806.45 kilopascal, what will be our D2? So our D2 is coming 222.71 micrometer. So this is the answer to this question. So C portion is also clear. So any doubt in this? Any doubt? Okay, nice. So let me move to the next portion. So we will quickly touch with some of the theory. So here, what is the need for advanced level spraying? So what happens with our sprayer is that in existing spraying system there is no cut-off mechanism to avoid spraying between the two plants. So what happens is, if our plant is here and our next plant is here, and if our sprayer is in continuous motion, so there is no provision to cut off the spray from here to here. Okay, so from here to here all your spray will be wasted. Okay, so this is one of the basic disadvantage of your traditional spraying. That means even if there is no plant in between spacing in between two plants, here there also we are spraying. So this is the main disadvantage of traditional sprayer. Okay, Now because of this, more than 50% of pesticide and fungicide are wasted in existing sprayer due to this no cutoff mechanism. And third thing is, this shows necessity of advanced level spraying system to obtain uniformity and saving in volume of spray liquid. So same thing, so again I am repeating, what happens is in traditional spraying is, if the plant is at distance, some distance apart, so our traditional sprayer has no cutoff mechanism. So in between this spacing also, your traditional sprayer will spray chemicals or fungicides or pesticides. So our spray, 50% of our spray will get wasted due to this. So to avoid this, we need advanced level spraying. So how we will move to advanced level spraying? Basically what we are doing, we are using an ultrasonic sprayer. So what is this ultrasonic sprayer? Ultrasonic sprayer is same sprayer with only ultrasonic sensors on it. So same sprayer, only the provision is we are putting two ultrasonic sensor. And this ultrasonic sensor, what they will do, this ultrasonic sensor generates high frequency sound waves and evaluates the echo which is received back by the sensor. So nozzle stops spraying if the plant is not present in front of the ultrasonic sensor. So by this, there is no wastage of the liquid in the system. So what will happen is, if we put this ultrasonic sensor in our sprayer will detect if there is plant or not. If there is no plant, then the ultrasonic sensor will command the microcontroller in such a way that the microcontroller will stop in the position in between two plants. So our spray will not be wasted in between two plants. So this is the concept. And how the ultrasonic sensor works? Ultrasonic sensor works on the principle of high frequency waves. So what will happen is, this ultrasonic sensor, let's say this is your ultrasonic sensor. This ultrasonic sensor will generate some sound waves, high frequency sound waves. If there is plant, then this sound wave will return back to this ultrasonic sensor. But here, if there is no plant, this sound wave will not return back. So this ultrasonic sensor is programmed by this way, that if the sound wave is receiving back to this ultrasonic sensor, then only it will spray. If the sound wave, it is not receiving the sound wave again, then at this position, this ultrasonic sensor will do no spray. So this is the principle of ultrasonic sensor. So here by a block diagram it has been explained here with a block diagram. So again same thing, if there if your sprayer in spray in both the direction, then you require two ultrasonic sensor, one here and one another here. So these are the two ultrasonic sensor, and this ultrasonic sensor will be connected to microcontroller. So when this ultrasonic sensor will receive the information, then it will say the plant is detected. If it will not receive the information, then plant is not detected. If plant is not detected, then there will be no actuation of motor or no actuation of sprayer. But if the plant is detected, like here, if the plant is detected, then what will happen is, this relay switches will get connected, and by this solenoid valve will spray the required chemicals to the plants. Okay, and if the plant is not detected, then the ultrasonic sensor will send this information to microcontroller, and there will be no actuation of this spray mechanism. So is this thing clear to all of you? Is this slide clear? Any doubt in this slide? Okay, so I hope this slide is clear. So now let's move to the next slide, that is drone in agriculture. Okay, now we have seen that all the spraying is done by a ground vehicle. Okay, till now what we have seen, all the spraying is done by a ground vehicle. But what happens is, we have this drone. Drone is, what is drone? Drone is UAV, that is unmanned aerial vehicle. Okay, so we can control this drone from the ground only. So this is the drone, and by drone in agriculture we can do many things. One such application is your variable one such application is your spraying or variable rate fertilizer spraying. Okay, this is one application. Another application, crop yield you can measure, like you cannot enter in between the field and calculate the crop yield. So what you can do, you can operate your drone above the field and your drone will give you the information regarding crop yield. Then spreading, or this is also some kind of spraying only. Then you can do the mapping part. Mapping part means in soil there will be some portion where there will be more fertilizer availability, but there is some portion there will be lack of nutrient availability. So your drone can map all those location where there is nutrient availability and where there is nutrient unavailability, so that you can do by your drone. Then crop monitoring means what happens is there could be some crop that requires monitoring because that crop could be deteriorated due to some reason, so we can use our drone in that purpose also. Then animal monitoring. Animal monitoring is one of the most successful uses of drone. What happens is, in large field and abroad, what happens is the cattle are grazing all over the field. So for a person to monitor the cattle is not possible. So you can operate your drone from your remote location, and that drone can collect information about your cattle. That means all your cattle are where exactly is your cattle situated. So that you can do by your drone. That is animal monitoring. Variable rate fertility we will discuss in the upcoming slide. Then diagnosis of diseases. Again, if there is dense vegetation, you cannot go in between the vegetation and diagnose the disease. So you can probably operate your drone from remote location. You can collect all the images of your crop, and by that you can diagnose the diseases. And last is water stress. Water stress, again, if some portion of your plant is wilting, so there is water stress, so that you can find out by your drone. So these are some of the application by your drone. But as we are studying spraying, so we will be focusing our discussion on drone related spraying. So how the drone will spray? Your drone will fly over your plants, and there will be some kind of index. Okay, if your drone will collect the data, and your microcontroller will calculate some kind of index that we will discuss in the next slide, like NDVI, or normalized difference vegetation index. So your microcontroller will be calculating some kind of index. If your data is more than threshold value, then only your motor driver will operate, and your pump will operate, and your nozzle will operate. Otherwise, if the value is less than a threshold value, then in that case your pump will not operate, and by that we can do the variable rate spraying. So again I am repeating, what you will do, you will operate your drone from remote location. The drone will go over the field. It will collect image data. Okay, the image data will be fed to the microcontroller will calculate some kind of index. If that value is less than threshold value, then your motor driver pump will not operate, and your nozzle will not operate. But if it is more than threshold value, then your motor driver, pump and nozzle will operate. So that is the principle of variable rate spraying. So these are some of the benefits of area spraying. Can treat crops faster than ground machine, because we are spraying from air, so it can treat crops faster than ground machine. Second is quick and timely application. Third is no yield loss due to wheel tracks, because whenever we are moving any ground vehicles in between the yield, so there can be yield loss. But in drone, we are flying this drone above the crop, so there will not be any yield loss. Fourth is no direct contact prevents spreading of disease. So as we are doing no direct contact with the crop, so there is prevention of disease. Fifth is no soil compaction. We are not using any heavy vehicles, so that is why no soil compaction. And last is applications are not limited by wet soil. What happens is we cannot operate our ground vehicles in wet soil, but here because we are applying this spray with drone in the air, so we are not limited to wet soil. So these are some of the benefits of your aerial spraying. Now this variable chemical spraying, this you will understand in detail. So what will happen is when you will fly the drone, your drone has some receiver and transmitter on it. So your drone will transmit all the signal to your ground control station, and ground control station there is a microcontroller, so that will do the image processing. And after the image processing, what will happen is the image processing data will be fed to the microcontroller, and microcontroller will decide if your microcontroller will decide by some kind of index. So that index is known as normalized difference vegetation index. So what is this? It quantifies vegetation by measuring difference between near infrared, which vegetation strongly reflects, and red light, which vegetation absorbs. So what happens is, any substance will have signature optical properties. Okay, any substance has signature optical properties. So if you will project some kind of light on it, it will behave differently. So your vegetation also behave differently to two kind of light: infrared light and red light. Okay, this two type of light, your vegetation acts different. So your vegetation strongly reflects this near infrared light, whereas the vegetation absorbs this red light. So this is the concept behind NDVI, and NDVI is calculated by this formula, that is NIR, near infrared minus red, divided by NIR plus red. So that you no need to care about the formula. What you will understand is this NDVI will give some value like 0.5 or 0.6 something. So let's say 0.5 is your threshold value. So if your threshold value is more than your value coming is more than threshold value, then only your variable microcontroller will operate this variable rate controller, and your actuator will operate. If your NDVI index is coming less than a threshold value, then your spray system will not get activated. So no spraying will be done at NDVI lesser than threshold, and spraying will be done at NDVI greater than threshold value. So this is the concept of variable rate chemical spray system. So any doubt in this? Any doubt in this? Okay. So we will cover the next topic, that is electrostatic sprayer. So this is the last topic. After that we will cover that assignment question. So what is this electrostatic sprayer? What happens is, what scientists have seen that the orientation of the leaves is, you can see the orientation of the leaves is basically basically in downward slanting direction. So what happens is, when the operator spray the chemicals onto the leaves, all the chemical get fallen due to gravity. So that is a disadvantage of your traditional sprayer. So your engineers or scientists come out by this concept of electrostatic spraying. So what is the concept of electrostatic spraying? Electrostatic spraying works on the principle of Coulomb's law. What is this Coulomb's law? The electric field from a positively charged point away from the charge, whereas the electric field from a negative charge point towards the charge. So this is your electrostatic spraying. So like the electric force, the electric field E is a vector. If the electric field at a particular point is known, the force charge Q experiences when it is placed at the point is given by F equals to QE. F is also vector and E is also vector quantity. So this is the electrostatic force F equals to QE. Q is the charge and E is the electric field. So that is the formula. Like F equals to MA. Okay. Similarly, in electrostatic, we call it F equals to QE. This Q or charge is equivalent to your mass is analogous system, and E is this is vector quantity and this is also vector quantity. So E is analogous to acceleration in your analog quantity. This is electrical part and this is your analog part. So this is the analogy. Okay, this is the electric part, this is the analog part. So this is your analogy. In analog part we call it F equals to MA, and in electric part we call it F equals to QE. F is the electrostatic force, Q is the charge, and E is the electric field. So this is the formula. Now what is the science behind this? This is Coulomb's law. So what happens in Coulomb's law is like charges attract each other, whereas unlike charges repel each other. So when the scientists have studied, what they find out is that leaf is positive in charge. Okay, and so the concept here is, if we apply a negatively charged sprayer to this droplet to this, then the droplet will stick to the surface of the leaf and it will not fall by gravity. So this is the concept. So here what we have been done, atomized droplet passed to an electrode inside the nozzle. Negatively charged electrons are attached to the droplets. Okay, so here we find out that your droplets are negatively charged and your plant is positively charged. So your plant will be your spray droplet will be attached to the plant surface or leaf surface with force that is 75 times greater than force of gravity. So by this, the spray droplet will be sticking to your leaves and it will not fall down. So this is the concept of the electrostatic sprayer. Now what are the advantages of electrostatic sprayer? Reduction in drift and increase in penetration of the crop canopy. So what happens is, during spraying, if there is more wind blowing, then your spray droplet will be drifted. Drifted means it will be off target. Okay, so if our spray droplet is negatively charged and plant is positively charged, then we can prevent this drift. Second thing is, reduce the amount required pesticide application by 30%, as the pesticides are not falling onto the ground by gravity, so we can reduce the amount of pesticide by 30%. Third is, deposition of liquid is enhanced 2-3 force because of this 75 times more electrostatic force than force of gravity. That is why the deposition of liquid is enhanced. Fourth is, electrostatic sprayer saves the overdose as well, chemical consumption, as thus preventing the environmental pollution. Okay, so this, as the liquid droplets are not falling to the ground and it is attaching to the leaf itself, so we are also preventing the environmental pollution. So these are some of the points regarding electrostatic sprayer. So any doubt in this slide? Any doubt why we are applying this electrostatic spraying and all this? Okay. So by this we are ending the theory. Now we will move to the assignment question. Okay. Yeah, now we will move to the assignment question, and this week assignment question are based on problem based on design and selection of spraying equipment 1 and 2. Third is ultrasonic sensor based sprayer, and fourth is drone assisted variable rate chemical applicator system and electrostatic sprayer. So this is the first question. In electrostatic spraying, the charging of a spray liquid can be achieved by: A is induction charging of conductive liquid, B is ionized charging of conductive or non-conductive liquid, C is direct charging of semi-conductive liquid, D is all of this or all of the above. So any guesses for this? Any guesses for this question? Okay, so D, option D, that is all of the above, is correct answer. We can do the electrostatic in electrostatic spraying. we can do the charging of spray liquid by all of these three methods, that is induction charging of conductive liquid, ionized charging of conductive or non-conductive liquid, and direct charging of semi-conductive liquid. All the three way we can apply for charging of the spray liquid. Only difference is in induction charging of conductive liquid, if we have conductive liquid and if we are doing induction charging, then the voltage we have to apply is 5 to 20 kilovolt. Whereas if we are doing ionized charging of conductive or non-conductive liquid, then the voltage we have to apply is 30 to 70 kilovolt. And direct charging of semi-conductive liquid, we have to apply a voltage 40 to 50 kilovolt. So option D is your correct answer, that is all of the above. Okay, so any doubt in this? Any doubt in this question? Okay, so let me move to the next question. The normalized difference vegetation index NDVI value ranges from A is -1 to +1, B is -1 to 0, C is 0 to +1, and D is 0 to infinity. So any, Gautam is telling A. So any other guesses? Okay, so yeah, absolutely right. Your NDVI is NIR, that is near infrared, plus R, sorry, NIR minus R divided by NIR plus R. So its value ranges from -1 to +1. Okay, value ranges from -1 to +1. Because in formula itself you can see, because NIR plus R is at the bottom, so it is denominator heavy, or denominator is more than numerator, so it will be always less than 1, and sign could be reversed, that R could be greater than NIR, so that is why it is going from -1 to +1. So option A is your correct answer. Okay, so let me move to the next question. An ultrasonic sensor is a sensor that measures the distance of an object using A is your infrared radiation, B is your high frequency sound pulse, C is light waves, and D is magnetic pulse. So any guesses for this question? Yeah, Gautam is telling B. Yeah, any other guesses? Okay, so B. Yeah, very good, Gautam. Yeah, ultrasonic sensor is based on measures the distance of an object using high frequency sound pulse. The name itself, sonic means sound, okay, and ultra means high. So by this also you can remember that ultrasonic sensor works on the principle of high frequency sound pulse. Ultrasonic, sonic means sound, ultra means high. So we are talking about high sound or high frequency sound pulse. So that is the principle behind ultrasonic sensor. So option B is your right answer. Okay, so let me move to the next question. Nozzle tips are made up of, option A is ceramics, option B is tungsten carbide, option C is brass, and option D is all of these. So any guesses for this? Yeah, Gautam is telling C, brass. Yeah, any other guesses? Okay, so what happens is nozzle tips are made up all the three components. Okay, A, B, C, that is brass also, tungsten carbide also, ceramics also. Brass, why we are using brass? Because these are durable and resistant to corrosion, and this is making them a common choice for general purpose application. Okay, they are cost effective and work well with agricultural spraying needs. But we also use ceramics as well as tungsten carbide. Tungsten carbide where we required exceptionally wear resistance. In all these cases, as well as we require high pressure spraying, in all these cases we use this tungsten carbide. And ceramic also we use in places where we want resistance to wear and corrosion. They are often used when spraying abrasive material or chemicals that may react with the material. So where we required inertness in reaction, in those cases we apply ceramics, because ceramics do not react with all these chemicals. So where we do not want any reaction with other chemicals, we use ceramics. We use tungsten carbide to have exceptionally wear resistance as well as high pressure spraying. And brass is the common choice, that is both durable as well as resistant to corrosion. So brass is our common choice, but we also use tungsten carbide as well as ceramics. So all of this, or D, is the correct answer. Okay, so this is the thing. Now let's move on to the next question. So next question is again a numerical question. So it has been given a tractor operated boom sprayer. A tractor operated boom sprayer is provided with a hollow cone nozzle for fungicide application at an application rate of 250 liter per hectare. So application rate is given. The next thing is given, the forward speed of the sprayer 6.5 km per hour. Forward speed is given, spacing is given 50 centimeter. The available 0.787 millimeter orifice diameter is rated at this much liter per minute at 275 kilopascal. The pressure required to produce desired nozzle flow rate is approximately equal to, so first we have to calculate the nozzle flow rate, that we have to calculate. How we can calculate nozzle flow rate? Nozzle flow rate is your application rate AR into your field capacity. Okay, by this we can get our nozzle flow rate. Application rate in liter per hectare, application rate in liter per hectare and field capacity in hectare per hour. If we can do this, we can get our nozzle flow rate at this much pressure, that is at a pressure at this much pressure, that is 275 kilopascal. Okay, sorry, this nozzle flow rate 0.575 liter per minute corresponds to 275 kilopascal. Now what is the pressure that is correspond to this flow rate, that we have to find out. So first we should find out this, that is Q, that is application rate into nozzle spacing into the speed, that this much portion divided by 10 is your field capacity, and this is your application rate, and divided by 60 when we will do, we can get our nozzle flow rate from liter per hour to liter per minute. So we are getting our nozzle flow rate as 1.35 liter per minute. Now we know that for this pressure, that is for this flow rate, that is for 0.575 liter per minute, our pressure is 275 kilopascal. This is the pressure. Now for this much flow rate, that is 1.35 liter per minute, what will be our pressure? What will be our pressure? That is the question. So for this we can find out, we know that P is directly proportional to Q square. Okay, P is directly proportional to Q square. So P1 divided by P2 is equal to Q1 divided by Q2 square. Q1 divided by Q2 square. Q1 we know 0.575. Q1 we know. Q2 we know 1.35. Q1 we know, Q2 we know, P1 also we know 275 kilopascal. So we can find out the P2. So again I am repeating, we first have to find out the Q. We have to find out the this Q, or the nozzle flow rate. How we can find out? Nozzle flow rate, application rate into field capacity. By this we can find out the nozzle flow rate, that is coming 1.35 liter per minute. Now in the question it has been asked, it has been told that for 0.575 liter per minute, the pressure is 275 kilopascal. Now for this 1.35 liter per minute, what will be the pressure? So you know pressure is directly proportional to Q square. So P1 by P2 will be equal to Q1 by Q2 square. So P1 we know, P1 that is 275 Pascal. We know the Q1, that is 0.575 liter per minute. We do not know the P2, but we know the Q2, that is 1.35 liter per minute. So by this we can find the P2. P2 is coming 1524.87 kilopascal. That is this option A is your correct answer. So is this question clear? Is this question clear to all of you? Any doubt in this question? Is my voice audible? Okay. Okay, so no doubt in this question, right? Okay, so I guess no doubt. So let me move to the next question. Again, this is a numerical question. The manufacturer of pressure nozzle specifies that a volume median diameter VMD of 150 millimeter obtained at 375 kilopascal pressure using water. Okay, he is testing this first with water. The same nozzle is to be tested with chemical whose surface tension is given 50 millinewton per meter. Now determine the volume median diameter of droplet size. The nozzle is operated at 550 kilopascal. So same type of question we have already done in the problem part also. Here two things are changing. One is we are changing the chemical. Second, we are changing the pressure. Okay, so when we are changing the chemical, we know this formula, that is V1 divided by V2 is equal to sigma 1 divided by sigma 2 to the power half. This formula we know. V1 is your let's say V1 is your chemical part, okay, and V2 is your water part. So V1 is your chemical part. V1 we have to find out. V1 we have to find out. Okay, V1 we have to find out. V2 we already know, that is by water, that is 150 millimeter. So V1 will be equal to 150 into sigma 1. Sigma 1 is for chemical, that is 50 millinewton per minute and millinewton per meter, and we know that chemical tension of water is 73 millinewton per meter, 73 or 73 dynes per centimeter. So that we also know. So if we will do this, we can get our VMD of the chemical, or V1, that we can get 150 into 50 by 73 to the power half. So by this we can get VMD of the chemical. Now in the second part we have been asked that if the pressure is changed, then how it will affect. So pressure also we know the formula, that is V1 divided by V2 will be equal to P2 by P1 to the power 1 by 3. So in this case we know the V1, but we do not know the V2. Okay, we have to find this V2. This we have to find out. Okay, this we have to find out. We know the V1 from this. V2 we have to find out. P2 we know. Yeah, P2 we know. P1 also we know. P2 is 550 kilopascal. P1 is 375 kilopascal divided by 1 by 3. So we will get the V1, and V1 is coming as 109.6 millimeter. So option D is your correct answer. So is this question clear? Any doubt in this question? Any doubt? Okay, so it is clear. So let me move to the next question. Again a numerical question. A boom sprayer is operating in rows at a speed 6.5 km per hour to cover 24 hectare in 8 hours. If 80% of the time is utilized in the actual task, then the boom length of the sprayer. Same type of question we have also discussed in our problem part also. So here what is the field efficiency? Field efficiency is AFC divided by TFC. Okay, and field efficiency here it is already given as 80% is your field efficiency. So it is already given 0.8. What is AFC? Now AFC is your actual area covered divided by actual time taken. So 24 divided by 8, 24 divided by 8, that is 3 hectare per hour is your AFC. Now what is TFC? TFC is S into W by 10. S we know, S we have already been given 6.5 kilometer per hour, and we have to find the boom length, or we have to find the W. So if we will solve this, you will get the W, or the width of the boom, or the length of the boom. S we already know, S is 6.5 kilometer per hour. Okay, S is 6.5. Okay, let me erase this. S is 6.5 kilometer per hour. So when you will solve this, you will get the desired answer. Okay, so you will get the desired answer, and your answer will come, W is 5.77 meter. That option D is your correct answer. So again I am repeating, you know what is field efficiency? Field efficiency is actual field capacity divided by theoretical field capacity. How we will find out actual field capacity? We have been given actual area covered divided by actual time taken. So 24 by 8, that will come as AFC. We have already given what is the field efficiency, that is 80%. So 0.8. This is also given. Now TFC, what is TFC? TFC is S into W by 10. S is the speed, W is the length or width of the machine divided by 10. Okay, so by this we can find out the width of the machine. So width of the machine will come as 5.77 meter. So this has been solved to you, and W is coming 5.77 meter. So is this question clear? Any doubt in this question? Any doubt? Okay, this question is clear. Now let me move to the next question. In the nozzle testing equipment, hydraulic nozzle are fixed 400 millimeter above the ground level, and a pressure 275 kilopascal is maintained. If the pressure is decreased to 1 by 16, then the percentage change in the flow rate of the nozzle at the spray angle 70 degree will be. So this thing is given additional information. We really don't need this thing. Also this thing, additional information, we do not require this thing. We know that pressure is directly proportional to Q square. Okay, so P1 by P2 will be equal to Q1 by Q2 square, or we can write this as Q1 by Q2 will be equal to P1 by P2 square root. This we can write. Now here it has been told that if the pressure is decreased to 1 by 16, so you let P1 be P and P2 be, P2 is pressure is decreased to 1 by 16, so P2 is P by 16. Okay, so P1 is P and P2 is P by 16. So Q1 by Q2 we can find out. Q1 by Q2 will be equal to P by 16. That means 16. That means Q1 by Q2 will be equal to 4. P by 16. So P will cancel out, and 16 will be at the top. Root over 16 is 4. So your Q1 will be equal to 4 of Q2. Okay, Q1 will be equal to 4 of Q2. Now here it has been asked what is the percentage change in flow rate. So what is the percentage change in flow rate? Percentage change will be equal to Q2 minus Q1 divided by Q2. Q1 minus Q2 divided by Q1 into 100%. This will be your answer. Now Q1 is Q1, Q2 is Q1 is Q1 is Q1, and Q2 is Q1 divided by 4. Okay, Q2 is Q1 divided by 4 divided by Q1 divided by Q1. So 1 minus 1 by 4 means 3 by 4. 3 by 4 into 100%, that means 75%. So C is your correct answer. Yeah, C is your correct answer. So any doubt regarding this question? So again I am repeating, P is directly proportional to Q square. So P1 by P2 is equal to Q1 by Q2 whole square. Now we can also write as Q1 by Q2 equal to root over P1 by P2. Now here it has been told in the question that the pressure is decreased to 1 by 16. So P1 is P and P2 is P by 16 because pressure has been decreased to 1 by 16. So P2 is P by 16. So Q1 by Q2 will be equal to P by 16. That means 16 root over 16. That means Q1 will be equal to 4 of Q2. Q1 will be equal to 4 of Q2. Now what is the percentage change in flow rate? That is Q1 minus Q2 divided by Q1. Q1 is Q1 whereas Q2 is Q1 divided by 4. So when you will solve this, this is 1 minus 1 by 4, that is 3 by 4 into 100%, that is 75%. So option C is your correct answer. So any doubt in this? Any doubt in this? Okay, this is clear. So nice. So let me move to the second last question. A piston type power sprayer has a stroke length this, diameter this. Yeah, stroke length is 30 millimeter, diameter is 20 millimeter. If the pump is to be operated at 1500 rpm, 3 plunger, then suction capacity. I have already told you the formula. Q is pi by 4 d square L, pi by 4 d square L into capital N. Capital N is your RPM and small n. Small n is your number of plunger. So same formula you can apply, pi by 4 into d square. D is diameter is 20 millimeter. That means 0.02 meter, 0.02 square. What is length? Length is, stroke length is 30 millimeter. That means 0.03. Okay, into d square is complete, L is complete. Now n is 1500 rpm, and again rpm means revolution per minute, but we want revolution per second. That is why we have to divide by, we have to convert minute to second. That means we have to divide by 60 into number of plunger. Number of plunger is 3. So when you will do the calculation, your answer will come as 0.707. Your answer will come as your answer will come as here 60 has not been divided. Yeah, here it has been divided. So your answer will come as 707. Your answer will come as 0.707 into 10 raised to the power minus 3 meter cube per second, and minus 10 raised to the power minus 3 meter cube is 1 liter. So your answer will be 0.707 liter per second. So option D is your correct answer. So is this thing clear? Q is pi by 4 d square L into n. Pi by 4 d is given, that is 20 millimeter or 0.02 meter, and stroke length is given 30 millimeter, that is 0.03 meter. Then RPM is given 1500 RPM, that we can convert to RPS, that is 1500 divided by 60, minute to second. That means we have to divide by 60 into number of plunger, that is small n, that is it has been given 3 plunger, so into 3. So you will get your answer in meter cube per second, that you can convert in liter per second. 1 meter cube equals to 10 raised to the power 3 liter. Okay, 1 meter cube equals to 10 raised to the power 3 liter. So you can convert this meter cube to liter and you will get this answer. So is this clear? Is this question clear? Okay, nice. Now let me move to the last question. A field sprayer with a horizontal boom, 12 nozzles. Yeah, 12 nozzles is given, number of nozzles is given, spacing is 0.40 meter, design for maximum application rate is also given, pressure is given, speed is given. If 10% of the pump output is bypassed under the above condition, then required pump capacity. Very simple. What you have to do? You have to calculate 12 into you have to what you have to do, your maximum application rate is given 350 liter per hectare. So application rate is given 350 liter per hectare. So I have already told you, your Q is your application rate into field capacity. Application rate here is liter per hour, sorry, liter per hectare, and your field capacity is a hectare per hour. So you can get your Q in liter per hour, and liter per hour you can change in liter per minute by converting hour to minute. 1 hour equals to 60 minutes. So you can get your Qn or the pump capacity that you can get, that is 350. Application rate is given 350. Now S into W by 10. What is S? S is the speed, that is 6.5. What is W? W is the 12 into 0.40. W is the total width of the machine, that is 12 into 0.40 divided by 10 into 60 because we have to convert hour into minute, that is why 60. 10 into 60 is 600. So that is why 350 into 0.4 into 6.5 divided by 600 divided by 600 into, we have to again into a number of nozzles, that is 12. Okay, number of nozzle, that is 12. So we will get the total flow rate of the pump. Now the second part of the question, 10% of the pump output is bypass. So we have to supply 10% extra. 10% extra means 1 point, we have to multiply our answer with 1.1. So our answer, final answer will come as 20.06 liter per minute. That is option B is the correct answer. So is this clear? Is this question clear? Any doubt in this question? Okay, nice. Okay, cool. So by this I am ending the session. Any doubt for today? Any slide you found it something difficult you want me to discuss again? Any part? Okay, so no doubt, right? Okay, nice. Okay, so by this I am ending the session for today. Okay, nice. So by this I am ending the session for today. We will meet on the next Tuesday. Okay? Okay. So bye. Okay, bye everyone. Okay.